Hi. So today we're going to go over adding and subtracting with like denominators and then a few that are unlike denominators. So remember, when you are adding or subtracting, you must have common denominators. So we're very happy that we got common denominators. So remember, when you add fractions, don't you keep the denominators the same? And then don't you add your numerators. So we're going to add those. So basically we're doing 10x plus the binomial 2x plus 6. And remember, when you're adding polynomials, you combine like terms. So that'll give you, if you combine like terms, we can combine 10x and 2x. And that gives us 12x plus 6. And just like anything, if you had, say, 1 6 plus 3 6, wouldn't you keep the denominator same and add the numerators, right? And then you couldn't leave your final answer this way. Wouldn't you have to reduce? So here we're going to factor out the 4 as 2 times 2 and factor 6 as 2 times 3. And then we can cancel common factors. So basically we're reducing by 2. So this is not necessarily your final answer. So the question is, can this be reduced? And if it can be reduced, you must reduce. So remember, to simplify a fraction is what we first started with in this chapter. So in order to reduce a fraction, you have to factor first. So we have to factor the numerator if it's possible to factor. And 6 is factorable out of that binomial. And that leaves me 2x plus 1. Double check that. Yep, that's good. And 8x is a monomial. It's already factored. And since this is a monomial factor, we can actually reduce 6 and 8 by 2. So if we divide each of those by 2, our final answer is going to be, so 2 goes into that 3 times, 2 goes into that 4 times. So our final answer is 3 times 2x plus 1 over 4. And that's your final answer. Sometimes on state tests, they might actually multiply that out, but most of us are pretty good. Most of us are pretty much okay with you just stopping here in its unmultiplied out form. So when you add or subtract fractions, you must have common denominators, and you just keep the denominator the same, and then you have to add the numerators, and then you have to reduce if possible. That's the main idea. So maybe on the next problem you can pause it and you can try it, and then you can go forward and see what you get. So let's go to the next slide. How about this slide? So why don't you pause it and see how you do? Okay, so did you keep the denominator the same? Right? So we're thrilled when we are adding or subtracting that you must have common denominators, so the denominator stays the same. And then don't you have to subtract the numerators? So it's x squared plus 9x, subtract 4x minus 6, right? So basically this is what you're doing. You're taking the first binomial, x squared plus 9x, and you're subtracting the other numerator, right? So remember, in the last chapter, we went over how to subtract polynomials. And when you subtract polynomials, don't you have to distribute? So isn't that going to give you x squared plus 9x minus 4x plus 6 in the numerator, right? Because you have to distribute that negative before you combine like terms, and then we can combine like terms. So x squared and then 9x and negative 4x are like terms. Right? So from there, we can reduce. Now, what you could have done instead of writing out all of this work, I just kind of wanted to show you, instead of doing all of this, right, you could have just made sure that you distribute this negative, change subtraction to addition, as long as you make sure you distribute that negative, and then you could combine like terms to get the numerator. And that's an easier way of writing it out instead of writing out all those steps that we wrote out earlier. And then the question is, can you reduce? Is that your final answer, or is this answer reducible? So remember, when you reduce, you got to factor everything first. So we're going to factor the numerator if it's factorable, and it probably is. So I wonder if it's factorable. And since this is a coefficient 1, if you want to use the diamond problem to help you find your factors, what could you multiply? It adds up. Multiply to give you 6. It adds up to give you 5. You know, what would your factors be? So it'd be x plus 3 and x plus 2. And then in the denominator, remember, the only thing that can be factored out of that one is a 1. So we can emphasize only a 1. And then we do have a binomial factor that can cancel out with that other binomial factor. So our final answer is x plus 2. We're not going to worry about undefined values this time around. So we're not going to list our undefined values. We're just going to worry about practicing adding and subtracting, right? So let's try another one. Again, maybe pause the tape and see if you can try the next problem, and then play it and see how you did. Okay, did you do this one? So we're happy because we see that they already have common denominators, so we can just keep the denominators same. And then we just subtract our numerators, right? And this is a super easy one. You probably thought it was too easy to be true. And remember, x and 8 are not like terms, so you can't actually subtract them. So all we can write is x minus 8 because they're not like terms, so there's nothing else we can do. And then the question is, can this be reduced? Well, let's see. I can only factor out a 1 from the numerator, and 2x is already factored, and there are no common binomial factors or common monomial factors. So it was not reducible. So this was in its simplified form. Be careful, because some kids will think they can cancel out this 2 with this 8. Nope. Or maybe they think they can cancel this x with that x. That's not true, because remember, this is a binomial package, and you can only factor or cancel a binomial package with another binomial package. Okay, let's see if you can do the next one. So what'd you do? We first notice that we have common denominators. Yay. So we keep the denominators same, and then we're going to subtract the numerators. So 6m minus 2. And then when we subtract the numerators, those are not like terms. And so that is 1 minus 3m. And then that's your answer. But can this answer be reduced? Question mark. So in order to reduce, you must factor. So the first thing I notice is that in the numerator, the m is not written first. So I remember I'm going to factor out a -1. By factoring out a -1, that switches the signs and the terms in the numerator. I notice in the denominator, I can factor out a 2. Double check. Yep. And then sure enough, I have a 3 minus 1 that can cancel out with the 3 minus 1. So my final answer is -1/2. How'd you do? Did you do it right? Did you think about factoring out the -1 from the numerator to get that to be turned around? Okay, let's look at the next one. So notice this one, we do not have common denominators. And this one is hard to explain. But basically do it underneath. and we have to come up with common denominators. So let's look at the 6 and let's look at the 3. We want to have a coefficient where 3 can go into that number and 6 can go into that number. So for an example, it could be 6, it could be 12, it could be 24, right? There's lots of numbers where both of them go into. That is called the lowest common multiple, right? The lowest common multiple. So basically what we're doing is we're doing multiples of 3, which are counting by threes. 3, 6, 9, 12, 15, etc. And then we're looking at the multiples of 6, which would be counting by 6, 6, 12, 18, 24, etc. And where are they common? They are common here. They are also common at 12, but we want the least common, so we want to use 6. So we're going to look at 6. So we want the lowest common. Now you could have used 12. It would still work out okay, but then you'd have reducing at the end, and we really don't want to have to do and get big numerators and get chunkier, answers where we have to really do ugly reducing. So it's always smarter to use the lowest common multiple. So 6, and then how do you find the multiples of the variables? Look at each of the variables. We have an x squared and we have an x. So we want to take the x that has the highest degree. So that means we need to have an x squared. And we have a y. We don't have any y's here, but we have to take at least one y. And so this is going to make up our common denominator. So here's going to be our common denominator. So I'm going to go back and erase this and clean this up a little bit. That's going to be our common denominator. You know you have a good denominator if what you see here is hiding inside here, if that makes sense. And this is just kind of hard to explain. And I don't think I'm going to be able to erase that without erasing everything. So here's how we got to go. You have to look at the denominator and say, what did you multiply the old denominator by to get the new denominator? And wouldn't you agree, it was just basically, it didn't change. So if the denominator didn't change, then the numerator is not going to change. However, in this denominator, what did we multiply 3x by to get 6x squared? So wouldn't we have to multiply that by a 2 to get the 6? Wouldn't we need to multiply by an x, because x times x is x squared, and then a y? So we would have to multiply 2xy to 3x to get the new denominator. Therefore, to balance the fraction out, we must multiply the numerator by the same amount, because that's really just multiplying, right? This is just a fancy way of saying 1. So when you multiply those together, don't we get 16xy? Now that we have common denominators, now we can add the fractions. So remember, we keep the denominator the same and we add the numerators. Remember, these are not like terms, so you cannot add them. So we can write 5 plus 16xy. Doesn't look like I can reduce anything because it's not factorable. So there's nothing that can be reduced. So I'm done. I cannot cancel any of these x's or 6 with this term up here because this is a binomial package. And there's nothing that can be factored out of that binomial package that I would have a monomial to cancel out with the monomial. So we are officially done. Okay, let's try another one. Those ones are the hardest. It just takes practice. Okay, what about this one? So we need a denominator, and a denominator. So obviously we're going to need a 3 because of this denominator. And both of these have n's. And this one is an n squared. So remember, we have to take the variable that has the highest degree. So this is going to be 3n squared. is going to be our new denominator. So now, since we've changed our denominators, we have to change our numerators by the same factor. So look at this old denominator and ask yourself, what could you multiply that old denominator to get this new denominator? So wouldn't we have to multiply by 3 times n to get 3n squared? So therefore, I have to multiply its numerator by 3n. So that gives me 12n. Then if you look at this denominator, wouldn't I have to multiply by just a 3? So therefore, I have to multiply its numerator by 3, which would give me 6. And then looking at this denominator, what would I have to multiply to get 3n squared? Wouldn't I have to multiply just by n squared? So I multiply its numerator by n squared. Now I can keep the denominator the same. And I can take 12n plus 6 minus n squared. And then I should maybe turn that around. And I wonder if anything's factorable. I can maybe factor out a -1 from this. That gives me n squared minus 12n minus 6. Is that factorable? Let's see, that's going to be, nope, that's not even factorable. And so I can't factor anything out of that, so this cannot be reduced. Now, can you cancel this 3n squared with this 3n squared? No, because this is a trinomial package. And unless you have another trinomial that matches that, you cannot cancel because of the plus signs. That's a package deal, and those are not factors. So you cannot cancel those n's. So your final answer is -n squared plus 12n plus 6 all over 3n squared. Let's look at a different, what if I had a to the third b squared c, say plus a b to the fifth c squared? What would be my common denominator? So I look at the a's, and whichever a, I have to take the a that has the highest exponent. So this one is a to the third, where this is only a to the first. So I have to have an a to the third in my denominator. Then I look at the b's. I have to select the b that has the highest power. And this one has the highest power. This is b to the fifth, where this is only b squared. So I have to have b to the fifth. And then I look at my c's, and I see this one is just a c, but this one's a c squared. And so 2 is higher than 1. So I have to have a c squared also. So that would have been my common denominator. Maybe that example will help a little bit about selecting common denominators when they're monomials. And then if you had like a 5 and a 2, then obviously this would have to be 10 to make that the common denominator. Okay, so let's try the one, I think. So maybe you can pause the tape and see if you can do this one, and then come back and see how you did. Okay, so what would be the common denominator? So I've got a 2 and a 3. So what number will 2 and 3 go into? And that would be 6. With the numbers, you can think of the lowest common multiple. The multiples of 2 are 2, 4, 6, 8, 10, etc. Multiples of 3 are 3, 6, 9, 12, etc. And where they're common is the lowest common multiple. Usually you can figure that out in your head. And then let's look at the variables. So we've got x's, x squared. So we have to take the one that has the highest degree for the x's. So we need x squared in our new denominator. Then we have a y to the fourth, a y squared, and a y. We have to take the y that has the highest degree. So we have to take the y to the fourth. So that is going to be our new common denominator. I think that's what I had written. Hopefully actually. So now we have to figure out, we changed the denominator. So we got to figure out, what did we multiply the old denominator to get the new denominator? So don't I need a 3 and an x, because x times x will give me the x squared, and I don't need any y's. So then I got to multiply its numerator by 3x as well. So that's going to be 3x. Then I have to look at the next one. What am I multiplying this old denominator by to get the new denominator? So I need a 6, and I need no x's, but I do need a y squared, because a y squared times a y squared will give me that y to the 4th. So I'm going to multiply the denominator by 6y squared to get the new denominator. So I must multiply the numerator by 6y squared as well. And so that gives me 12y squared. And then what do we need to multiply this old denominator to get this new denominator? So I need a 2, because 2 times 3 is 6. I need an x squared, and I need a y to the 3rd power to get me y to the 4th. So therefore I have to multiply the numerator by the same amount. And when I multiply that, I get 8x squared y cubed. Now I can add and subtract. Keep the denominator the same, and then add the numerators. And there, unfortunately, there's nothing I can do with that, because they don't all have an x in common. They don't all have a y in common. If this numerator right here had been a 4x, like let's just pretend it had been a 4x. Like, right, we're pretending like if, then couldn't I factor out a 4 from each of these? Right? Couldn't I factor out a monomial 4, and wouldn't that leave me x plus 3y squared plus 2x squared y cubed over 6x squared y to the 4th? And then couldn't I reduce those monomials? So if these all had something in common, that I could factor something out, and then I had common factors that I could reduce, like a monomial with a monomial, then I can do that. But for this, I do not. So that was if. So there's nothing. This cannot be reduced. I can't factor anything out of this. So that's as far as I can go. Okay, I hope this helped a little bit.